last week lecture we had discussed about microsensors and microtransducers, about the overall fundamentals of microsensors and microtransducers. So we had discussed about the different sensing elements, different transaction elements, and we also had a good amount of discussion about the optomechatronic systems, different modes of optomechatronic systems, how optical fibers are used for microsensing and microtransduction. So this week we will discuss about the gyroscope accelerometers, mechanical switches, flow transducers, haptic interface and sensory skin for microrobotic systems. So as a part of this particular course, now let us discuss about the micro gyroscope accelerometers. So the term gyroscope conventionally referred to the mechanical class of gyroscopes, which is derived from the ancient Greek language, being the physics of a kind of a precision motion. So these gyroscopes, also named as gyro, measures the angular rate around a fixed axis with respect to the inertial space. So if we try to classify these gyroscopes, so the gyroscopes can be classified based on the domain: mechanical domain, quantum domain and the optical domain. So when we take this mechanical domain, so it is classified into two. One is called as a classical gyroscope, another one is called as a vibrating structure gyroscope. However, in the case of an optical based system, so we can classify it as fiber optic gyroscope and a ring laser gyroscope. Now let us take the classification of this vibrating structure gyroscope. So the vibrating structure gyroscope are classified into four. One is called as tuning fork gyroscope, the ring gyroscope, hemispherical resonator gyroscope, dynamically tuned gyroscope. Now when we look into the classical mechanical gyroscope, a mechanical gyroscope consists of a spinning wheel or disc, also known as the rotor, mounted on a frame. The frame, which allows for a freedom of movement in 2 or 3 planes, comprises a gimbal system. The basic principle behind a gyroscope is the conversion of angular momentum, a property that states that a spinning object will continue to spin about its axis unless acted upon by an external torque. When the rotor spins at high speed, the gyroscope exhibits two main properties: rigidity in space and precision. This rigidity in space refers to the gyroscope's ability to maintain its orientation in relation to the fixed points in space. So the precision, on the other hand, occurs when an external force is applied to the gyroscope, causing it to change its orientation at a right angle to the direction of the applied force. As far as application of the classical mechanical gyroscope is concerned, navigation system in ships, aircrafts and spacecrafts, gyro compass for determining the true north, inertial guidance system in missiles and satellites, stabilization of large boats and cameras. So the great advantage, a good amount of advantage these gyroscopes has, basically on high accuracy for detecting the rotational motion, provide stability and maintain directions in moving object. As far as limitation perspective point of view, it can be noisy compared to modern alternatives, mechanical wear over time, and it has a large size compared to the MEMS gyroscope. So this is the overall construction of the gyroscope. So basically, as mentioned, it has a gyroscope frame, a spin axis, a rotor and a gimbal which takes care of the entire functionality of the gyroscopes. Now let us discuss about the vibrating structure gyroscope. The working principle of vibrating structure gyroscopes, also called as Coriolis vibratory gyroscope, is based on the Coriolis effect. As known, Coriolis effect refers to the generation of an imaginary force perpendicular to the moving direction of subject within the rotating coordinate systems. So these vibrating structures, gyroscopes utilizes the Coriolis effect to convert the rotary motion of the subject into a measurable linear motion. So the figure basically it shows the trajectory of a ball thrown from the edge of a rotating disc as seen by an external observer. Because of the rotation, the ball has both an initial tangential velocity and radial velocity given by the thrower. These velocities bring it to the right of the center. Similarly, when we try to talk about the right figure, the trajectory of the ball thrown from the edge of a rotating disc as seen by the thrower, the rotating observer, it is deviating from the straight line as shown over here. Now, imagine that an observer is sitting on the x-axis of a rotating coordinate system. Around z-axis observes a moving particle traveling at the velocity v in the space. Because of the rotating coordinate system, the particle has a trajectory towards the x-axis with an acceleration of 2 volt ohm from the view of the observer. This apparent acceleration observed in a rotating coordinate system is called as the Coriolis acceleration, proportional to the rotation rate of the coordinate system and the travelling velocity of the object v. According to this phenomenon, a gyroscope without any rotary parts can be designed, which consists of 2 sets of mass spring damper system positioned in a perpendicular direction as shown over here. So this is the kind of a traveling particle along the Coriolis acceleration, and this is the kind of proof of mass which is being kept with reference to the spring. So this basically corresponds to the Coriolis effect, and mass spring dasher system, which basically corresponds to the vibratory gyroscope. So the main advantage of such kind of gyroscopes are it is compact and lightweight, no moving parts except for vibration, and it increases its reliability. It has most important point is it is for a low power consumption, so it has a potential usage in a micro robotic applications. It is suitable for MEMS technology enabling mass production. As far as limitation perspective point of view, it has a gradual output deviation over time, reducing long term accuracy. External shocks and vibration disrupts measurements accuracy. Performance varies with temperature changes requiring compensation. As far as application perspective point of view, it is used in consumer electronics, basically in smartphones and gaming controllers, automotive stability control system, aerospace in navigation in aircraft and spacecraft, robotics, motion sensing and control. Now, as far as this vibration structure gyroscope is concerned, the vibration structure gyroscopes are classified based on the functionality as ring gyroscope, tuning fork gyroscope, hemispherical resonator gyroscope, dynamically tuned gyroscopes. Let us go in detail into it. Let us first discuss about the tuning fork micro gyroscope accelerometer. So as far as in this tuning fork gyroscope accelerometer is concerned, so 2 parallel beams of times that vibrate in opposite direction, and drive twine oscillates in a plane, typically in XY plane, sense mode and out plane or out of plane vibration Z axis caused by the Coriolis force when rotated. The tines are typically driven at their resonate frequency using electrostatic or piezoelectric actuation. When the gyroscope experiences angular rotation, the Coriolis effect causes a secondary vibration orthogonal to the drive motion, which is detected by the measure the rotation rate. The major advantage is the differential operation cancels common mode noise and doubles output signal, and high sensitivity due to resonant operations, compact size especially in MEMS implementation, low power consumption compared to the other gyroscope types. Next, let us discuss about the ring micro gyroscope accelerometer. So as far as in this ring micro gyroscope accelerometers, so if we see the overall construction, it has anchors, and then there is a ring kind of structure which is connected to the anchors, which is in the form of an elastic beam, and it has an inner electrode inside, and it has a kind of a sensing which sense the driving and the sensing. So ideally it consists of a thin ring suspended by support beams, electrodes around the ring for actuation and sensing. The ring vibrates radially in its primary mode. When rotated, Coriolis force causes deformation in orthogonal mode. The magnitude of this secondary vibration is proportional to the angular rate. The major advantage of this particular ring micro gyroscope accelerometers are, like, as far as advantages are concerned, it is compact in size, especially in MEMS implementation, low power consumption, suitable for integration into various devices, can detect around multiple axes with a single structure. So these are the key advantage of this ring micro gyroscope accelerometers. Now let us discuss about the hemispherical resonator micro gyroscope accelerometers. So as far as in this hemispherical resonator micro gyroscopes, so if we closely observe the construction, there is going to be an excitation. This excitation is analyzed using a network analyzer which acts as a sensing electrode, and there is a driving electrode which is available. So a hemispherical resonator gyroscope is also known as a wine glass gyroscope or mushroom gyro. It is a high performance angular rate or rotation sensor with no moving parts. This thin solid state hemispherical shell anchored by a thick stem, the shell driven to fluxural resonance at its natural resonant frequency by electrostatic force from the surrounding electrodes. This utilizes inertial property of a fluxural standing waves for gyroscope effect. When subjected to angular rotation, the Coriolis effect causes the standing wave pattern process to rotate relative to the resonator. So the amount and direction of this precision are directly proportional to the angular velocity of the rotation. The key advantage of this particular hemispherical resonator micro gyroscope accelerometers are, it is highly accurate and insensitive to external perturbations. It is superior in size, weight and power characteristics, generates no acoustic or radiated noise. Radiation hard fused quartz material are used. Ultra low angular random walk and power dissipations are some of the major advantage of these hemispherical resonator micro gyroscopes accelerometers. Now let us talk about the dynamically tuned micro gyroscope accelerometers. These dynamically tuned micro gyroscope is a high precision angular rate sensor used in inertial navigation and guidance system. It consists of a rotor supported by a flexible joint with two pairs of orthogonal torsion bars and a balancing ring frame. The rotor is driven by a spin at a high speed of over 10,000 rpm by a miniaturized motor. It uses a negative elastic moment from dynamic effects to offset positive elastic moment of torsion bars. It operates in a free rotor state without torque and improving the gyroscopic precision. As far as advantages perspective point of view, it is suitable for applications which is requiring precise measurement in challenging environments. It has a high accuracy, it has a wide dynamic range and low drift. As far as application perspective point of view, aviation and spacecraft navigation systems, marine navigation systems which include ships and submarines, missile guidance systems, oil field exploration and development systems, robotic and autonomous systems are some of the key examples or key applications of these dynamically tuned micro gyroscope accelerometers. Now let us discuss about this quantum gyroscopes. These quantum gyroscopes are highly sensitive device that measures angular rotation based on a quantum mechanical principle, particularly the Josephson effect and the quantum interference. Now, these optical gyroscope, which is nothing but the quantum gyroscope, can be classified into two. One is called as a fiber optic gyroscope and the other one is called as a ring laser gyroscope. First, let us discuss about the fiber optic micro gyroscope accelerometers. These fiber optic gyroscopes are highly precision sensors that measure angular velocity using the Sagnac effect. So, in this particular construction, so two important process which comes into the picture. One is the light signal injection and the other one is the interference detection. So, there is going to be a rotation in place and these two will act as the input and the analyzing parameter for this particular fiber optic micro gyroscope accelerometers. So, in this particular process, two laser beam are injected into opposite end of a long optical fiber coil. When the fiber optic gyros rotates, the beam traveling against the rotation experience a shorter path delay. The resulting phase shift is measured through an interferometry. The phase shift is proportional to the angular velocity. Now, the key advantage of these particular fiber optic gyroscopes accelerometers are it doesn't has any moving part. So, which is considered to be one of the key advantage, so that it doesn't has any impact on the system on which it is mounted, and it has an increase in reliability and lifespan. It has a high accuracy and stability. It is immune to electromagnetic interference. It has a wide dynamic range and it has an instant startup. It is compact and lightweight. As far as an application perspective point of view, these inertial navigation system for aircraft, ship and submarines, the altitude control in spacecraft and satellites, oil and gas industry for directional drilling, robotics and autonomous vehicles, military system for targeting and stabilization. Now, let us discuss about this ring laser micro gyroscope accelerometers. These ring laser micro gyroscope accelerometers are high precision device used to measure angular velocity based on the Sagnac effect. If we see the overall construction of this particular ring laser micro gyroscope, so here like the light beams are used and then there is a helium gas which is used, and then the electrodes are placed in this particular orientation. There is a piezoelectric dither motor and a servo driven mirrors in place to guide the laser appropriately. Now, if we closely observe the working principle of this ring laser micro gyroscope accelerometers, there are two laser beams are generated to travel in opposite direction. That is, one is in the clockwise and the other one is in the counterclockwise within the ring cavity filled with the gaseous medium. So, in most of these cases, the gaseous medium is helium neon. These beams form two independent resonant modes over the same optical path. So, the frequency difference is measured to determine the angular velocity of this particular system. As far as advantages perspective point of view, similar to the earlier case, it doesn't has any moving part. It has an increasing durability and reliability. It has a high accuracy and precision. It is compact and lightweight design. It has an instant startup capability. It is highly resistant to high G-force and vibrations. As far as application perspective point of view, these are inertial navigation system for aircraft, ship and spacecraft, and military system for targeting and stabilization, and it's an autonomous vehicles and drones are effectively used by these fiber optic gyroscope accelerometers. Now, let us discuss about the next part which is related to micromechanical switches. So as far as switches are concerned, so we all are well aware about it. Switches are mainly meant for controlling. Switches are also controlling, and switches are have a control over the displacement as well as the position. So if we need to reach a particular position, these switches can be effectively used to position our system based on our requirement or the characteristics. Now in this particular aspect, the micromechanical switches, basically these are basically meant to use a physical movement to make a break or break electrical connections. As far as an evolution perspective point of view, when a simple mechanical contacts to sophisticated electromechanical system, it's an essential component in nearly all electronic devices and systems. The fundamental operation perspective point of view, these physical contacts between conductors to control electric flow, technological progression has driven the miniaturization and its enhanced capability. Let us see a simple template of these micromechanical switches. So in this micromechanical switches, if we keenly observe, we have two electromagnetic coils in place. There is a polymer which is a kind of a diaphragm which is being placed over here. So and then there is a magnet which is available. So this magnet will have a control over the movement, and based on the frequency or based on the requirement, appropriately these electromagnetic coils will be helpful for us to give a kind of a displacement or a kind of a characteristics to this particular system. Okay. So the overall potential actuation is taken care by these electromagnetic coils and the kind of a magnet which is available over here. So based on this movement, so you can observe you can have a control over the frequency as well as the vibration. So if we observe the basic working principle, this is a physical contact operation between a conducting element, and force application causes a displacement of a movable contact. The circuit completion occurs when contact touches and allowing the current to flow. As far as mechanical restoration is concerned, the mechanical restoration is through spring, or sometimes in the case of a diaphragm, so that the diaphragm itself will try to bring the mechanical restoration. So basically we try to select the materials appropriately so that these mechanical restorations are being deployed. Then with reference to key components, it has a fixed contact, it has a movable contact, and then it has an actuation mechanism, restoring the mechanism and housing it appropriately based on our requirements. There are two types of mechanical switches are there. One is called as a reed switch, another one is called as a micro switch. As far as these reed switches are concerned, these reed switches are glass encapsulated metal reeds that responds to the magnetic field, and it has a non-contact activation through the proximity of the magnetic field. As far as micro switches are concerned, so these are small precision switch with defined point and physical contact with the lever button. Let us see the overall configuration in this. So as the name suggests, in this particular case, this is called as a reed, and we have a magnetic field which is available in place. This magnetic field is used for actuating these reeds. So initially it is in an open state. If we need to close it appropriately, we try to bring the magnetic field closer to it so that it becomes a closed state. Now with reference to lever perspective point of view, there is a kind of a spring which is available, and there are two contacts which are established. A lever is being attached, and then appropriately we get the actuation in the LEDs. Now in these two conditions, the reed and the lever are used for sensing the position and it gives out appropriate actions. Now let us discuss about the next configuration, which is called as the membrane switches. So as far as these membrane switches are concerned, these membrane switches comprises of thin flexible layers with printed circuit. The pressure creates a contact between the circuit. Now, this configuration we had already discussed, where we have two electromagnetic coils. There is a magnet in place, a polymer and a movement in place. So, this thin flexible layer will try to move back and forth, and appropriately this has a control over it has a capability towards actuation and sensing. Okay. Now, let us talk about the snap action switches. These snap action switches has a spring loaded mechanism for rapid state change. So, it provides a tactile feedback through a distinctive snap action. So, if we see the overall fundamental of it, it has a fixed system with an electrical coil. In certain cases, either it might be a shape memory alloy spring or it might be a kind of a excited spring, which means it has a coil which is being connected over here. So, the movement is controlled in such a way that there is a heater is placed. So, this heating will take care of the movement of this electrical contact, the movable system which is moving back and forth. So, like it is almost equivalent to a solenoid. So, in the case of a solenoid, we have a magnetic field. Here, the spring plays a vital role in controlling the overall action. So, that is why this is called as a snap action switches. Now, we can also discuss about the MEMS based switches. So, we will discuss about this MEMS based switches in the upcoming lecture.